Hi, my name is Jonathan, and welcome to Configuring Transport Side Connectivity Part 2. This is the continuation of Part 1, hence calling it Part 2. All right, and we're talking about extending that transport side to the existing device. Okay, so we have a protocol we're going to be running called bidirectional forwarding detection, which because the whole purpose of this is to detect link failures as part of the SD-WAN high availability solution. It's enabled by default on all vEdge routers, and you can't disable it. Basically, the configuration is automatic. It's going to be there no matter what. Basically, the only thing you really can do with it is you can specify how often it sends packets in on the transport tunnel, and then it uses these packets to detect the liveliness of the tunnel connection and faults on the tunnel. You can specify how many hello packet intervals to wait before declaring the tunnel has failed. Basically, we'll determine that it's failed when during all these intervals BFD has received no hello packets on the tunnel. The interval is a multiply of the hello packet interval time, just like other hello intervals. And basically, you can specify how often it's going to poll all data plane tunnels on a vEdge router to collect packet latency, loss, and other statistics used by application-aware routing. So this guy is going to be really important for two reasons. One, whether or not an internet connection is up or not, and to fail over to the other one. Right? That's condition number one. That one's important. But there's another condition, which is why we really love SD-WAN. The SD-WAN's kind of cool. So let's say I probe both of these sides, right? And one of them says its latency is 60 milliseconds. And the other one says its latency is 900 milliseconds, right? I'm going to move traffic to the one with the lower latency for the protocols that are more affected by high latency in the communication. So for example, real-time voice and video communications. We're going to want to make sure that traffic goes over the circuit that's best capable of handling it. Okay? Generally, what we're going to find is we're going to probably run most of that low latency traffic over our MPLS connections because they're more likely to have QoS. As far as I know, there is no internet-enabled QoS circuit on the planet yet. Just so you're aware, I want you to note on this before we discuss any further, none of these devices are directly connected together. So there's no links like that. All right? That does not exist on any of these. Okay? So the ideal scenario is that both vEdge routers are multi-homed and directly connected to every transport provider. So this vEdge has an internet connection and an MPLS connection, right? And the other side does as well. So even though we have two redundant vEdges, both of them share the same services. It isn't like one is connected to MPLS and the other one's connected to the internet. Okay? They're both equal. Basically, the SD-WAN tunnels, overlay tunnels are built through all directly connected transports, so both of them are basically the same. They're essentially a mirror of each other. All right? Either side provides the same thing. So during a circuit failure, both edge routers maintain WAN connectivity to at least one transport provider. During a transport failure, both edge routers maintain WAN connectivity to the remaining transport provider. In the case of a router failure, the remaining edge router maintains connectivity to both transport providers. Okay? So, for example, on this guy, if we fail this internet connection, so in this case, this guy's got the internet connection. The internet's here. So if we lose this connection, right, this guy still has it, and from this side, we'd actually advertise that route from here instead of there, for example. So if there's a circuit failure, a transport failure, or an entire router failure, right, we still provide services no matter what. This is the ideal. While it's relatively easy for a single site to have multiple internet connections for both devices, it's a little harder to pull off an MPLS unless you have redundant MPLS connections at a site. Generally, that's a little harder to do. Okay. Now we have our routers connected directly together, but they're not sharing circuits. So this router only connected to the internet, and this router is only connected to the MPLS. Okay? So on a circuit failure, right, if we lose internet connectivity, we have to route all traffic through MPLS. And the same thing here. Okay? In small offices, by the way, you're probably going to have one vEdge. This doesn't really apply. So you only have if we have one vEdge, all the connections are connected to it. So the only redundancy is going to be path redundancy over what circuits remain. If we have two and they both don't have the same connections, unlike the previous slide where they did, right, we need some way to fail over through the other vEdge. Okay? When every vEdge router is connected only to the given transports, you can use TLOC extensions through local and remote transports even though they're not directly connected. Okay? And we'll show you how to do that in a couple of slides. Basically, we're going to connect the v-edges together and then bind an interface locally to the other v-edge, right? So you can't really see it yet. We're going to have better diagrams in the coming slides on how this actually is wired up. Because the way we wire this is half of the fun of this, okay? Basically, we're going to bind an interface which connects the other edge's v-router, another v-edge router at the same site to the local router's WAN transport interface, okay? By the way, you can configure the two routers themselves with different site identifiers. Whoops, sorry, you cannot. So these need to be in the same site ID. I apologize for that one. Okay. Basically, the physical interface on the local router that connects is going to connect to the WAN transport circuit, and that interface can be an Ethernet or a PPP interface or something else. All right. So the question is how do we make sure that since we only have one connection, so WAN edge 2 is connected only to MPLS. Sorry. WAN edge 2 is connected only to MPLS, and WAN edge 1 only has an internet connection. Okay? So in this case, each v-edge does not have a connection to the other. So what we're going to do is we're going to use this idea of a T-lock extension. We're going to basically drag some like amoeba pseudopod out from WAN edge 1 and 2 to the other device. Okay? So for instance, so this v-edge 2, right, wants to get internet connection, so we're going to connect this interface up that way. And vice versa. And similarly, on WAN edge 1, we don't have an MPLS connection. We're going to do the same thing with WAN edge 1 through WAN edge 2. Now note, all of these interfaces are in VPN 0. So from a WAN edge device, from the v-edge device, these are all tunnel interfaces. Okay? And then what we do is we create a static route for each of these devices. So this will be a static route for those subnets going that way so that we route to the other side. Okay? Let me erase these so we can do some more notes on here. Okay? And then we NAT the GigE02 on WAN edge 2 to our ISP, right? So we NAT this exactly the same way we would as if this had a local internet connection. But from his perspective, he has an internet connection right here. From this perspective, we're extending that connection that way using this command T-lock extension GigE02. So under GigE02, for instance here, so under this interface, we add this command to extend the T-lock of GigE00. So we bring that down to there, and then from here, he sees this as a regular tunnel interconnection, which is being advertised this way from GigE02, dragging down his GigE00. Okay? So now remember, if we're doing this with some other device, we may need to configure this somewhere else. That's with static routing. We can do this also with dynamic routing. Okay? If we have now we may not have this capability, but let's say we're doing this with our provider edge, and the provider will basically let us use BGP and OSPF between us to advertise these routes that way, okay? So that we can get those routes over to the WAN edge 1, okay? We're still providing NAT. We're still providing internet access this way, the same way we were before on the previous slide, using that T-lock extension. Again, extending GigE00 down, okay? All right. And service BGP or OSPF is going to be allowed on that T3 interface up here because we want to talk this way. Now, if this MPLS provider router is not under your control, you're going to have to coordinate with your provider to get them to do that. But if that's your CE router, all right, then it's something you can configure yourself and just enable the BGP or OSPF. And the upside here is this dynamic routing. We don't have to create static routes. Okay. So basically, we can also do this with internet with a loopback interface if we wanted to, as opposed to doing this with a physical interface. So we create a loopback on WAN edge 2, this guy up here, all right, if you're curious as to where it was hiding on this diagram. And then T2 and T3, these guys, are going to be dynamically advertised as they are all part of VPN 0. WAN edge 2's loopback, we're using that instead of GigE00. Okay? This way we do dynamic routing for WAN edge 2 on GigE00 and the MPLS provider edge. So those two are talking directly. And then we're not required to allow BGP or OSPF on this T3. Right? It'll get it because it's part of VPN 0. All right? Remember, if we're part of VPN 0, we're going to dynamically share that via OMP, and there's no configuration required for OMP. Okay? And here's another option of doing it completely statically. We can have a static route to T2, right? So we're going to advertise, so this side we're going to have a route advertised, a route advertised that way, all right? And then we're going to have a same thing with the MPLS this way. This is if we have two MPLS providers at the same site, terminated on different devices, okay? And you'll notice that these two are the same color, and these two are the same color, all right? That means that they're sharing their connections so that they'll form tunnels between them. All right, now let's do dual MPLSs with dual routing between the two. All right. The only difference here is how we're getting these routes from the MPLS A and B to the other WAN edge service. Dynamic versus static before. So we have BGP and OSPF configured on T1 and T3. All right. Notice these are different colors, so they're only going to form with those local connections. We now have, and then dynamic routing between WAN edge 1 and the MPLS, and WAN edge 2 and the MPLS. And we can use either BGP or OSPF, whichever one the provider supports or we're comfortable with. And then T1 and 4 are dynamically advertised from WAN edge 1 to MPLS A, right? Because those colors are connected. So those are going to be dynamically advertised. And then these two are going to be dynamically advertised. All right? Easy. And this is the same thing, but we're doing it with loopbacks, so we're not running the BGP and OSPF on our 0.0 interface, which is similar to the loopback before. Okay? When you start seeing these V-edges, multiple V-edges, and you start seeing the way we need to connect the sites together to make sure that we have connectivity, you realize we have a lot of power here, right? Because even though this guy has no physical connection to MPLS-B, with the way this is configured to this loopback and we're dragging this TLOC extension out, all right, we actually pretend that this guy has a direct connection to an MPLS router even though he does not. Another way of describing this, let me show you another way of drawing this so that it looks a little bit more, well, maybe weird, but let's see what it looks like and we'll see that. Imagine if this router was actually shaped like this. All right, that the router actually had this little section out here that we could actually have connected directly to us, okay? So this entire thing is dragged off to be that way. So it's not a separate event. It looks like the same large squishy device. Okay? And how do we configure this in the GUI? Well, you've seen the commands here. So these are the commands that we'd be typing on the router, right? But of course, we're probably going to be vmanage configured. Those are the commands that will show up when we configure it via vmanage. So I'll go to feature template for the device. And then what we're going to do is hit advanced on under the VPN interface for that site, and then TLOC extension. All right, and it covered it up, but on here there's like a little box that says on or off, and you would check the button. Okay, and here's what that looks like in on the CLI. All right, so we have our VPN 0 interfaces. Okay, they're all VPN 0. Here's our static routes that we're going to be using. And here's our TLOC extension. So this gig 03, I'm going to show you this one just as an example, is a TLOC extension of gig 00. So this is local, right? These aren't separate things. Gig 02 is a tunnel interface. So here's the other side. We also have a gig 02 is a TLOC extension for gig 00. Okay, so that brings those that way, and that brings this that way. And that way we share those connections even though we're on separate devices. And notice that we have static routes on both sides. And you'll notice that our default route here, right, is a 5.52.1. Sorry, 52.51, which is this guy. So the default route is pointing at the other side. And you'll notice here we have two default routes. Sorry. We have two default routes. One of them is pointing on the TLOC extension. So let's get rid of that. Yeah, okay. So one of them, our primary default route is this guy, right, for MPLS. And then we have a second one going to this 10.551.52 that way, right? So that's how I do my static routes inside the box. So when every vEdge router is connected only to one given transport, you're going to have to use the TLOC extensions to get the other transports sucked over to the other device, right? Realistically, this sounds like it's going to be an odd scenario, but the reality is that you probably have one MPLS connection and one internet connection at your site, and you're going to want some redundancy. If I give you one vEdge router connected to both, that's awesome, as long as that vEdge router has power and is up and those connections are up. But as soon as if a vEdge router fails, your options are to get another vEdge router out there or to put a second vEdge router in place, run VRRP on the inside, and then provide the same connectivity from both devices. And the best way to do that is with TLOC extensions. All right? That concludes the TLOC extension section, and it also includes this section of the class. So basically, we've been talking about how vEdge routers support BGP and OSPF, and we can be part of your regular OSPF or BGP domain. We also have fault detection using BFD, bidirectional forwarding detection. We also measure the quality of experience on each interface to see if it's working correctly. And whenever vEdge router is connected only to one transport, we can use the TLOC extensions to connect through the local and remote transports, even if they're not directly connected. And that concludes this section. Thank you very much for watching.